Hello, my name is Miss Hanley, and today we're going to talk about absolute value equations and how to solve those. So, absolute value, if you recall, is a number's distance from zero on a number line. And if you remember, distance is never something that's going to be negative. Think about if you move 6 feet, no matter what direction you go, and you're still moving a certain amount of feet. Maybe if you move backwards, you might think it's negative, but there's no sign attached to that. It's just how far you went, and that's always positive. We can't have negative distance. The world would be crazy, unless you get into a black hole. So if you think about absolute value of -7, it's just going to be 7, because we're 7 spaces away from 0 on a number line. Absolute value of +7, also 7. So if you look at what just happened, we have two different numbers. They both spit out the same answer. Well, that's going to happen when you have absolute value equations because you're looking for an unknown. That unknown could be two different things because multiple different values will give you the same answer. All right. So there are a few steps to solving an absolute value equation. The first is to isolate your absolute value. And that means that if you have a number added or multiplied outside, you need to get rid of that first. All right. Your second step is to create two different equations. And one of those will be equal to a positive answer and one will be equal to a negative. All right, for the third, you're going to solve both of those separately. And then lastly, you want to graph your answers, graph your solutions. Okay, so let's go down and see if we can solve a couple of these examples. For example 1, we have the absolute value of x minus 3 is equal to 8. Well, my first question for you would be, is our absolute value alone? And I don't see any number multiplied or added outside. So if that's the case, then our absolute value brackets are totally fine. So step 1, where we say isolate absolute value, we can sort of skip. So we just get absolute value of x minus 3 equals 8. Simple enough. Make sure to make your absolute value bars a little bit longer so you don't mistake them for ones. Now the time comes when we want to think about what's actually going to give us an 8 as an answer. Well, there are two numbers that will give us 8 out of absolute value. One is positive 8, and the other is a negative 8. So two different kinds of values will give us the answer of 8, two different values. Well, when we figure that out with an equation, this one happens to be simple, but they might not be this simple. We want to create two different equations. So for my first equation, I'm going to call it equation A. I'm just going to write what we have in our problem without absolute value brackets. So x minus 3 is equal to 8. So that means I want whatever's in the middle here to come out to equal 8, and that will make my answer true. For my second equation, I want to take whatever was in the middle, x minus 3, but instead of it being equal to positive 8, it's now equal to negative 8. So once we've created those two equations, now we're just going to solve them separately. But if you notice, it's the exact same steps to solve both. So if I have x minus 3, I'm adding 3. So I end with x equals 11, and x is equal to negative 5. Now you always want to go back and check those. So if we substitute these back in, is 11 minus 3, well that gives me 8. Is the absolute value of 8 equal to 8? Yes. Right, so 11 minus 3, that checks. On the other side, we would have negative 5 minus 3. Well, that gives me negative 8. The absolute value of negative 8 is still 8. So we're all set with both checks. And when we graph an equal to an equation solution on a number line, you're only going to have that one number. So we need a negative 5 and an 11. And since they're equal to, we're including them. So you're just going to have a closed circle above each. Alright, one last one, same steps to follow. This one adds a little bit of a trick for us though. So if we look at what's happening now, the difference between example 2 and example 1 is that example 2 has a 2 in front of our absolute value. So treat absolute value almost like you would parentheses. The first thing that we have to do is get rid of that. And so if it's outside of that, it's being multiplied. So here, I'm going to divide both sides of my equation by 2. And if we're treating this like x plus 4 like parentheses, that means that we're not touching anything inside of it. The 2's are canceling out front like a fraction would. So we bring down absolute value of x plus 4, and that's going to be equal to a 5. Next, we have to create two equations. So x plus 4, this would be my A, is equal to positive 5. For B, x plus 4 would be equal to negative 5. Steps to solving them both are the same, so take away 4. Here we have x equals 1 and x equals negative 9. So I'm going to do a mental check here. 1 plus 4 is going to give me 5. Absolute value of 5 is 5, so that checks. Negative 9 plus 4 is negative 5. Absolute value of negative 5 is going to give me 5. Also checks. So now if I go down, we can plot negative 9 and positive 1, and that's all there is to it. The only thing I would caution you of is if you ever get n equals negative 14. When we were just talking about distance, we said that there can never, ever be negative distance, which means we can never have an absolute value equation come out to equal a negative. So I don't care what number x is, you're never going to get the absolute value of something to be equal to a negative number. So if you ever recognize this, that would be a no solution.